Hi guys, this is 2024 AMC 8 problem 20, and we're looking at this geometry problem here. And it says that any three vertices of the cube P, Q, R, S, T, U, V, W, shown in the figure below, can be connected to form a triangle. How many of these triangles are equilateral and contain P as a vertex? So we're wanting to find equilateral triangles that contain this vertice as one of its vertexes. So we can see here that in this cube, we can have a couple of different sizes of line segments possible to form a triangle, right? So we could have a line segment, we could have sides that are just along the sides of the cube. This is one of the possibilities. Another one is one of the diagonals of the squares, or one of the not face diagonals anymore. These are space diagonals. So the longest diagonal that connects points across from each other in this cube. So we have three different types of line segments. We can't make any other types. And the only way to get equilateral triangles is with face diagonals, right? The ones that are part of these squares. Like, so for example, the one connecting PV, because any other way, right, we can see that if we had just with the side lengths, any way that we go, if we take the next length, that's the side, we're always going to get this like 45-degree right triangle, right? We won't be able to get an equilateral triangle in any way. Same thing for the space diagonals here. So like if we have connecting from R to W to R, there's only one possible space diagonal that contains one of these points here, right? So if we were to connect W or R to anything else, it would no longer be a space diagonal. For example, like here or like here, it would no longer be a space diagonal. So it won't work. We can't make equilateral triangles from space diagonals. Instead, the only way is through these face diagonals. And from here, we can see that there's a couple ways to do this. We can, any face diagonal that we connect here to this first one will create an equilateral triangle. Since these are all space diagonals, it's an equilateral triangle. Now we're trying to find how many equilateral triangles we can make from this vertex here, from P. So what we want to do is, let's say we know that there's PV, PR, and PT as possible face diagonals that come off of P. Those are only face diagonals. So we know that every single one of the equilateral triangles from P will have to at least contain one of these lines. And then we can also prove that it has to contain at least two, because in order to get back to P from another vertex, in order to get back to P, first of all, it also has to be a face diagonal, and of course, it also has to connect to P. So no matter what, when we create an equilateral triangle from P, it has to have two line segments coming off of P, which means that for each of our equilateral triangles, we need to use at least two of these line segments. So either PT, PV, or PR, we need to use two of them, right? So then from here, we can tell that if it's PR and PV, there's only one possibility since we have to connect these lines. And same thing for all the other ones. So the ones with PR and PT have to have TR. And I think the lines get a little confusing from here. And if it's from PT to PV, we need TV. So any sets of two from this set of three lines off of P, we know that we can make one equilateral triangle from it. So since we have three ways to make sets of two from PR, PV, and PT, we know that our answer has to be D, 3. All right, thanks, guys.